All right, last section on the high-level bits and pieces of Agile methods, and then we'll get into some example processes that are actual Agile methodologies. Again, just wrapping up from what we had previously, plan-driven versus Agile, you have many more cycles. They're much tighter integrated. And then the maintenance phase ends up being variable in scope rather than fixed. So you may end up adding things to the 1.0 product that would have to be required for the planned version. Here's some planning guidelines for most Agile processes. They don't spend much time planning. It's generally a very short horizon, 3 months at the absolute most. And generally, you're not going to get that far. Most of the time, it'll be about a month. You'll have small releases and much more regular iterations. You saw that on the previous slide. And you're going to be soliciting customer feedback for each of those iterations, if possible. Usually it'll be every 2 weeks, 1 month at the absolute most. Project tracking is going to be used to change what you deliver in your next iteration or in the iteration after that. Whereas in a traditional process, much of the project tracking has been done very early on before you even really begin doing development. That's sort of like the outline of everything you need to do, and tracking is just, are we on schedule or off schedule? Requirements in an Agile process can be complicated, right? You can't have a lot of complexity there, but usually not until you have implementation do you have a requirement set that you would think of as like a thorough description of what the stakeholder is actually interested in. So you're going to start off with very partial descriptions of what the software system is going to look like at the end of the day. For quality assurance, this is an even larger differentiation than traditional plan-driven approaches. In Agile, quality assurance is part of the everyday life of development, especially in something like a test-driven development process. You're going to have at least some part of this done every single day when you're doing development. Again, verification versus validation, very important to recognize the difference between the two. If you don't have them top of mind, definitions top of mind, pause the video, think of your definition, and then restart the video, and I'll give you kind of the breakdown. So verification is, do we actually have, are we building the product right? Basically, do we actually have the code working in a way that we would want it to work and that we would want to maintain it? Validation is, are we building the right product? Meaning, is this something the customer is interested in? And both of these are part of quality assurance. You're going to be doing them every single day, and these are just ways in which the Agile approaches typically do that. Unit testing obviously helps with verification. Most Agile processes do not include formal code reviews. That may actually be a little bit problematic for long-term software development, and there are some approaches, some Agile approaches, that will have like a retrospective code review that will help with that after you've finished an iteration. Validation, on the other hand, you're going to have much more regular customer feedback, and so you can ask the customer on much more regular intervals, is this what you want? Is this actually working? It may not end up happening every single day, but you would definitely be doing verification every day, and that is a critical piece of quality assurance. All right, now we get to the big payoff. We've seen this chart before. I've overlaid plan-driven versus Agile, and this is somewhat speculative. There's no really good research showing definitively that this is how Agile changes the cost of change curve. But with a plan-driven approach, you start off in the definition phase with lots of very easy to make changes because it's all basically paper at that point. And then you get into development, and by the time you end up releasing the software, making changes to it are very, very expensive. In an Agile process, there's a little bit more cost doing changes early on simply because you aren't going to know everything early on, right? Even if you did a very basic plan up front, you'd be able to make those first several iterations much better in an Agile process. But you don't want to do that because you really just want to get into the building code, get into the process of meeting with your customers on a regular basis. And eventually, at some point during development, you have this crossover point where it's actually cheaper to continue making change and to adapting to change using an Agile process than with a plan-driven approach. So these are really strong statements. It's one of the real key differences between Agile and traditional approaches. Traditional methodologies are stated in a way that you would definitively work if carried out correctly, but it's generally impossible to carry them out correctly, or perfectly, I should say. Agile methods are stated in a way that's generally correct, but it's impossible to know if you're going to get a definitively correct, perfect version for your output at the end of the day. So each of these statements, I think, make Agile methods what they are. The one in bold here about test-driven development encouraging good object-oriented design, again, it's a strong statement. We don't have lots of evidence proving this to be a correct statement from a scientific standpoint. But it is sort of the sense that the community has that if you're using test-driven development, you'll end up with somewhat better object-oriented design. These are all things that you might be able to get into a bar fight over, right? Is it possible that frequent collaboration with stakeholders makes things easier or just more frustrating, right? Because stakeholders don't really know what they want. Is it possible that collaborating in a pair programming environment actually reduces the risk of personnel turnover? Well, maybe. Depends on the pair. Maybe you really like working with your pair and you, as a result, don't decide to look for a job when you normally would. Is it possible that getting customer feedback after these small increments actually does change the product direction in a low-cost fashion? Who knows? These are all things that I think would make for great research projects in Agile software development. But I think they're also things that most of the people in the community would say are true, common wisdom of Agile software development. All right, in the next section, we'll go through two example Agile methodologies, and then we'll wrap up with a very brief introduction to lean software development and Kanban as a process management technique.